National Electrical Code Section 400.8 addresses restrictions on flexible cords and cables. Specifically, 400.8 focuses on the protection of electrical equipment. Electrical equipment that is likely to be exposed to physical damage must be protected. 400.8 concerns working space about electrical equipment rated 600 volts, nominal or less. Sufficient access and working space must be provided and maintained around all electrical equipment to permit ready and safe operation and maintenance of such equipment. Now let's delve into practical considerations for compliance, particularly in the context of a 12-foot power cord and non-metallic, or NM, in-wall cable. A 12-foot power cord is susceptible to physical damage. Common hazards include being stepped on, pinched by furniture, or subjected to abrasion. To mitigate these risks, consider the following measures. Firstly, running the power cord through a conduit offers robust physical protection, shielding it from impacts and compression. Secondly, employing a cord protector, such as a cable ramp or similar device, can prevent damage in areas where foot traffic or equipment movement is likely. Now let's look at an NM cable. NM cable, commonly used for residential wiring, isn't as rugged as metallic options like BX or NEC cable. Therefore, protecting an NM cable installed within walls is crucial. One way to protect an NM cable is similar to power cords, which is to run it through conduit. Conduit provides a rigid barrier against physical damage from nails, screws, or other objects that might penetrate the wall. Another method is to utilize a cable protector, especially in areas where the cable is exposed or runs close to the surface. Beyond the specific requirements of 400.8 and 400.8 WO, several additional factors should inform your approach to electrical equipment protection. One such consideration is the location of the electrical equipment. Electrical equipment should ideally be situated in a location that minimizes exposure to physical damage and moisture. Avoid areas prone to dampness, impact, or excessive vibration. Another important consideration is the type of electrical equipment. Different types of electrical equipment exhibit varying degrees of vulnerability. For instance, motors and transformers, with their moving parts and potential for overheating, are generally more susceptible to damage than simpler devices like light fixtures. Ensure that appropriate protective measures are implemented based on the specific characteristics of the equipment. And another important consideration is the importance of the electrical equipment itself. The criticality of the electrical equipment should also factor into your protection strategy. Critical equipment, such as that powering essential life safety systems or vital industrial processes, warrants a higher level of protection than non-critical equipment. Redundancy, backup power supplies, and enhanced physical barriers may be justified in such cases. Let's expand upon the concept of working space about electrical equipment. Adequate working space is essential for safe operation, maintenance, and repair of electrical systems. The specific dimensions of the required working space are detailed in NEC Section 110.26. These dimensions vary based on voltage levels and the presence of exposed live parts. Firstly, ensure sufficient depth for personnel to safely access and work on the equipment. This depth should be measured from the front of the equipment to any obstruction, such as a wall or adjacent equipment. Secondly, provide adequate width to allow for free movement and access to all components of the equipment. This width should be sufficient to accommodate personnel and any tools or equipment needed for the task. Thirdly, maintain adequate height clearance to prevent accidental contact with overhead obstructions such as ceilings, pipes, or other equipment. This clearance should comply with NEC requirements and any applicable local codes. When installing electrical equipment, consider the potential for future expansion or modifications. Leave sufficient space to accommodate additional equipment or wiring without compromising safety or accessibility. Avoid overcrowding electrical panels or equipment rooms, as this can hinder maintenance and increase the risk of accidents. Regularly inspect electrical equipment and working spaces to identify any potential hazards or deficiencies. Look for signs of damage, overheating, loose connections, or obstructions. Promptly address any issues to prevent accidents and ensure continued safe operation. Remember that proper grounding is essential for electrical safety and equipment protection. Ensure that all electrical equipment is properly grounded in accordance with NEC requirements. Grounding provides a path for fault current to flow back to the source, tripping circuit breakers or ground fault circuit interrupters, or GFCIs, and minimizing the risk of electric shock. When selecting electrical equipment, prioritize products that are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or ALL, or Electrical Testing Laboratories, or ETL. These listings indicate that the equipment has been tested and meets established safety standards. Use appropriate personal protective equipment, or PPE, when working on or near electrical equipment. This may include insulated gloves, safety glasses, and arc-rated clothing. Follow all safety procedures and guidelines to minimize the risk of electric shock, burns, or other injuries. Train personnel on the proper operation, maintenance, and troubleshooting of electrical equipment. Ensure that they are familiar with relevant safety procedures and emergency response protocols. Regular training can help prevent accidents and improve overall electrical safety. Maintain accurate and up-to-date documentation of all electrical systems, including wiring diagrams, panel schedules, and equipment specifications. This documentation can be invaluable for troubleshooting, maintenance, and future modifications. Periodically review and update your electrical safety program to ensure that it remains effective and compliant with current regulations and best practices. Seek input from qualified electrical professionals to identify areas for improvement and address any emerging hazards. By adhering to these guidelines and recommendations, you can significantly enhance the safety and reliability of your electrical systems and ensure compliance with the NEC and other applicable codes and standards. Remember that electrical safety is a shared responsibility, and everyone should be committed to creating a safe working environment. It is vital to consult the specific requirements of the National Electrical Code and any local amendments that may apply in your jurisdiction. The NEC is a comprehensive set of standards designed to ensure the safe installation and operation of electrical systems. Familiarize yourself with the relevant sections of the code and seek guidance from qualified electrical professionals when necessary. Proper planning, installation, and maintenance are essential for ensuring the long-term reliability and safety of your electrical systems. By taking a proactive approach to electrical safety, you can minimize the risk of accidents, prevent equipment damage, and create a safer environment for everyone. Consider engaging a qualified electrical contractor to conduct a comprehensive electrical safety audit of your facility. An audit can help identify potential hazards, assess compliance with applicable codes and standards, and recommend corrective actions to improve electrical safety. Implement a lockout-tagout program to prevent accidental energization of electrical equipment during maintenance or repair activities. Lockout-tagout procedures ensure that equipment is de-energized and isolated before any work is performed, minimizing the risk of electric shock or other injuries. Regularly test ground fault circuit interrupters, or GFCIs, to ensure that they are functioning properly. GFCIs are designed to protect against electric shock by detecting ground faults and interrupting the circuit. Test GFCIs monthly or as recommended by the manufacturer. Ensure that all electrical panels and equipment are properly labeled to identify the circuits they serve. Clear and accurate labeling can help prevent confusion and errors during maintenance or troubleshooting. Install surge protection devices to protect sensitive electronic equipment from voltage spikes and surges. Surge protection devices divert excess voltage away from the equipment, preventing damage and extending its lifespan. Use arc flash hazard analysis to determine the appropriate level of personal protective equipment, or PPE, required for working on or near energized electrical equipment. Arc flash hazard analysis takes into account the potential energy released during an arc flash event and helps ensure that workers are adequately protected. Promote a culture of safety within your organization by encouraging employees to report any electrical hazards or concerns. Create a system for reporting and addressing safety issues promptly and effectively. Stay informed about emerging electrical safety technologies and best practices. Attend industry conferences, read trade publications, and participate in online forums to stay up to date on the latest developments. Remember that electrical safety is an ongoing process, not a one-time event. Continuously monitor and evaluate your electrical safety program to ensure that it remains effective and responsive to changing conditions. By investing in electrical safety, you are protecting your employees, your equipment, and your business. A safe and reliable electrical system is essential for productivity, profitability, and overall success.